Hello friends, Mr. Burrell here. We are in this final trigonometry unit, Unit 13. We just finished talking about the area of oblique triangles, non-right triangles, and you'll notice that the rest of what we do in this unit has a lot to do with non-right triangles. A lot of the trigonometry that we've done thus far has been associated with things that we know about right triangle trigonometry and those types of relationships. The rest of this unit is going to be about things that we can do to solve for missing sides, missing angles, when triangles are not right, when we're not dealing with right triangles. So to start that, we're going to talk about the law of sines. Sine being, sine, cosine, tangent, that sine. When we're talking about sines, not signs from the heavens or road signs. We're talking about trigonometry, law of sines. Again, we've done a lot of trigonometry with right triangles in the past, solving for missing sides, angles, but there are lots of examples out there in the real world of non-right or oblique triangles. What about those? We don't want them to feel left out. So that's what we're going to talk about. Today, by the end of this video, I hope that you are able to know the law of sines. We'll talk about what that is and what it means. I want you to be able to use the law of sines to find a missing side length and use the law of sines to find a missing angle. And then in a shorter post after this video, I'm going to talk about, this is an honors topic, determining what to do in an ambiguous case. And I'll talk about what that means. So before we start talking about the law of sines, I want us to try something. So in your calculator, I've given this triangle. This is just a triangle that I created and I labeled with all the corresponding angles and sides. In your calculator, I want you to find the ratio of each of the sides of this triangle to the sine of the opposite angle. In other words, I want you to take side A divided by sine of angle A, side B divided by sine of angle B, side C divided by sine of angle C. So this side divided by the sine of this angle, this side divided by the sine of this angle, this side divided by the sine of this angle. So this is side C, side B, and side A. So we're taking each of these sides and dividing it by the sine of their opposite angle. So take a minute and do that. You can pause the video, do that real quick, and I want you to see what you notice. So I'm going to write them out real quick. So 15 divided by the sine of 77 degrees. Let's see. B is 15.16 divided by the sine of 80 degrees. And then we have 6.02 divided by the sine of 23 degrees. So in your calculator, do those math problems. Do each of those math problems. Do the sides divided by the sine of their opposite angles and see what you get. Round to the nearest tenth. So this is what I get. For this one, I got 15.4 rounding to the nearest tenth. For this one, I got 15.4 rounding to the nearest tenth. For this one, I got 15.4 to the rounded to the nearest tenth. Huh. Coincidence? Coincidence that all of those fractions simplify to the same decimal? That all those ratios are the same? No. Not a coincidence. That is what we call the law of sines. So if I have any triangle, triangle ABC, then this relationship is going to exist. The ratio of a side divided by the sine of its opposite angle is going to be the same for every single side and that corresponding opposite angle. So A divided by sine of A divided by sine of A is going to be equal to B divided by sine of B, which is going to be equal to C divided by sine of C. And same inverted. Sine of A divided by A is going to be equal to sine of B divided by B, which is going to be equal to sine of C divided by C. That ratio is always going to exist. That's crazy. That's so cool. I think that's nuts. So in each of these, keep in mind that the capital letters usually represent the angles, and the little letters usually represent the sides. So again, the ratio of the sides to the sine of their opposite angles all will be equal to each other for every triangle. So that relationship, that knowledge can come in handy with solving for different sides and different angles of a triangle. So another way you can look at the law of sines, I'll look at it this way because usually we're dealing with one equal sign. So A divided by the sine of A is equal to B over the sine of B, or B over the sine of B is equal to C over the sine of C, or C over the sine of C is equal to A over the sine of A. Basically the same thing as I said on this previous slide, just written out as 3 different equations. And then I have the same thing here. The same relationship exists if you flip those fractions upside down. Those ratios are always equal to each other. Now let me explain why that's helpful, why that's useful. And again, this isn't a relationship that you necessarily need. Well, this is a relationship I want you to remember. This formula is one that you can write down, that you can use. Questions like this often pop up on the ACT. The law of sines is a likable question to use on the ACT. But anyways, I'm going to now explain where do we use this, why do we use this, how is it helpful. So this problem might be an example of a problem you might see on the homework or on the ACT. It says find each measurement indicated, round your answers to the nearest tenth. Okay, so here I have angle B and I have angle A. And this is side A, side B, and side C here, those opposite sides. And I know side C, and I'm wanting to find AC. So I'm wanting to find this side right here. Another name for AC, I can identify it as B. Well, previously, I would be able to find this missing side using what I knew about right triangle trigonometry. If I knew one of these angles was 90 degrees, I could solve using right triangle trigonometry, sine, cosine, and tangent. But this is not a right triangle. But notice here that I have 2 angles and I have a side. So I'm going to show you how we can use the law of sines to solve for this missing side right here. So first thing, in the law of sines, I have A over the sine of A is equal to B over the sine of B, which is equal to C over the sine of C. So in order to use the law of sines, I at least need to know a side and an angle opposite that side. So this is the only side I know, so I'm going to need to know this angle. So remember that all the angles on the inside of a triangle add up to 180 degrees. So if this angle is 104 degrees, this angle is 20 degrees, 180 minus 104 minus 20 is 56. So this angle right here is 56 degrees. So with the information that I'm given here, I'm going to go ahead and write out an equation. So A, I don't know yet, but A over the sine of 20 is equal to B over the sine of 104. And that's also equal to C, or 29, over the sine of 56. And I'm trying to solve for B right here. So I'm going to ignore this part of the equation. I don't even need to worry about that, because right now I'm going to solve for B. So I have one unknown variable in this equation here. Okay, so I'm going to go ahead and compute these 2 values, sine of 104 and sine of 56. Sine of 104 is 0.97, so I'm going to go ahead and put B divided by 0.97 equals, and then 29 divided by sine of 56. Sine of 56 is 0.829. 0.970 and 0.829. Okay, now I need to solve for B. So method to do this you may be pretty familiar with. I'm going to go ahead and cross multiply. Does that ring a bell at all? I'm going to cross multiply. So I'm going to transfer this equation and I'm going to multiply each of these terms together. So I'm going to get 0.829 times B. And then on this other side, I'm going to have 29 times 0.970, which is 28.13. 0.829 times B equals 28.13. Well, now, in order to solve for B, I'm going to go ahead and divide by 0.829. I'll cancel this jazz out. 28.13 divided by 0.829 is 33.93. So this side right here, B, is equal to 33.93 inches. Depending on how you rounded, your answer might be a little bit off of that, but approximately 33.93 inches, that's the length of this side. I didn't need to know that that was a right triangle in order to solve that. I just needed to know about the law of sines. Okay, So I'm going to go ahead and skip number 2. You can do that one in your own practice time. I'm going to go ahead and skip on to the next page here. So on this page, we're talking about finding missing angles. So here, for example, this says find measure of angle A. So I'm wanting to find this angle right here. I can still use the law of sines because I at least know one angle and the side opposite that angle right here. So this is angle A, angle B, angle C. So that means this is going to be side A, side B, and side C. So let me set up my law of sines relationships. So 24 over the sine of A is equal to 28 over the sine of 91, which is equal to C over the sine of C. Well, I don't need this. I'm not solving for C, so I don't need this part of the equation. I just need 24 over sine of A is equal to 28 over sine of 91. Okay, well, sine of 91, I can type that into my calculator, making sure my calculator is in degrees. Sine of 91 is, I'm going to round this out to a lot of decimal places. I have 24 over the sine of A is equal to 28 divided by 0.9998. Really close to 90 degrees, so it's really close to sine of 90 degrees, which is 1, but not quite. Then I'm going to cross multiply. 24 times 0.9998 is 23.996, which is equal to 28 times the sine of A. Then I'm going to divide by 28. 23.996 divided by 28 gives me 0.857 equals sine of A. Canceled all that jazz out and left with 0.857 equals sine of A. Well, I have the sine of A. If only there was a way to undo sine to solve for an angle. Man, there is a way to do that. Because I undo sine with the inverse sine, the second button in my calculator. So A is equal to the inverse sine of 0.857. The inverse sine of 0.857, the inverse sine of 0.857 is 58.98 degrees. So this angle right here is 58.98 degrees. We're about really close to 60 degrees. And now if I wanted to keep going, I could go ahead and finish solving for like this angle and this side, but since I'm just asked to find the measure of angle A, I'm going to go ahead and stop right there. Okay, so again, I'm going to skip number 4 so we can go over some homework problem examples. But that's the law of sines. We can use the law of sines, the knowledge that the ratio between a side and the sine of its opposite angle in a triangle are equal to each other with all of those sides. We can use that knowledge to solve for these missing parts. Later on, probably in the extra stuff that we do in this trimester, we're going to talk about some real-world examples where you can utilize the law of sines to calculate distances, to calculate angles, things like that. So something to look forward to. So in your homework, it says find each measurement indicated. This problem right here is number 6 off your homework. It says find BC. So we're going to find this side right here. Okay, I'm going to go ahead and label these sides according to their angles. So this is angle A, B, C. So this is side A, side B, and side C. So I'm going to go ahead and set up, well, first of all, I'm going to make sure that I can use the law of sines. Because I can only use the law of sines if I at least know a side and its opposite angle. Otherwise, the law of sines doesn't do me any good. Well, this is the only side that I know, so I'm going to need to know this angle at least. Well, good thing I know the other two, because I know that all the angles inside of a triangle have to add up to 180 degrees. So 180 minus 36 minus 27 is 117. So this angle right here is 117 degrees. Now, let's set up my law of sines relationship. So A over the sine of 36 is equal to B, or 47 over the sine of 117. which is equal to c over the sine of 27. Well, I only need this side of the... I'm not looking for c. I don't really care right now about this side. What I'm worried about is finding this side BC, or side A. So this is the part of the equation that I'm concerned with. Okay, so I'm going to rewrite this expression except with those decimals for my sine values. So sine of 36, that's 0.5878. We'll round to 4 decimal places. So A over 0.5878 equals 47 over the sine of 117, which is 0.8910. So then I'm going to go ahead and cross multiply. So cross multiplying, I get 0.8910 times A equals 47 times 0.5878, which is 27.63. And then to solve for A here, I'm going to divide by 0.8910, because that'll cancel 0.8910 on this side. And 27.63 divided by 0.8910 is A equals 31. Basically, almost exactly 31. So this side right here is 31 meters long. 31 meters long, and I found that using the law of sines. And I could go ahead and solve for this side also using the law of sines if I wanted to keep going. Okay, let me erase some of this jazz. We'll work on question number 10 on the homework. This one is going to be including finding a missing angle. Okay, so first of all, let me double check that I can even use the law of sines. In order to use the law of sines, I need to know a side and an angle opposite that side, which in this case, I do. Okay, so I'm going to label these sides as A, B, and C, opposite their respective angles. And I'm after this angle right here. I'm trying to find angle C. So let me write my law of sines relationship. A over the sine of A, or 14 over the sine of 41, is equal to B over the sine of B, which is equal to C, or 8, over the sine of C. Well, I'm not worried about B or angle B. I'm not trying to find those right now, so I can ignore that part of the equation. So here's my equation. 14 over the sine of 41 is equal to 8 over the sine of C. Well, let me go ahead and type in the sine of 41 in my calculator, get that decimal. So this can be written, let me write a little arrow here, as 14 over 0.6561 equals 8 over sine of C. Then, I'm going to go ahead and cross multiply. Can't simplify this sign yet. So if I cross multiply, I go ahead and get 14 times the sine of C is equal to 8 times 0.6561, which is 5.2485. And again, according to how you're rounding, you might get slightly different decimals here. So I have 14 times the sine of angle C is equal to 5.2485. So since 14 is being multiplied here, I'm going to divide by 14 on both sides. And 5.2485 divided by 14, I've just been leaving these numbers in my calculator. I get sine, I'm going to write up here, sine of angle C is equal to 0.3749. Well, that's not my answer yet. That doesn't even really make sense as a measure of an angle, because that's what the sine of angle C is. So in order to find angle C, I have to do the inverse sine of 0.3749. The inverse sine of 0.3749 is about 22.02, or about 22, we'll round it to 22 degrees. So this angle right here is 22 degrees. And then with that knowledge, we could go on to find the measure of angle B, etc., etc., etc. Okay, let's do one more homework problem. I won't completely finish this homework problem, but I will get it started. So this problem, instead of asking you to solve for a specific side, it just says solve the triangle. So in a problem where it says solve the triangle, it wants you to solve for every missing side and every missing angle. So let's do that. So right off the bat, I'm given two angles, so I can find angle C right off the bat here by taking 180 minus 94 minus 32, which is 54 degrees. So angle C is 54 degrees. That's great. This is side A and this is side B. I need to find both of those. In this video, I'm just going to find one. I'm going to leave you to be able to find the other one. But let me write my relationships here. So A over the sine of 94 is equal to B over the sine of 32, which is equal to C, or 26, over the sine of 54. So those are all equal to each other. That's what the law of sine says. So depending on what we want to solve for first, that will depend on what I set equal to 26 over sine of 54. So if I wanted to solve for A, I just have A divided by sine of 94 equals 26 divided by the sine of 54. If I wanted to solve for B, I'd have B over the sine of 32 is equal to 26 over the sine of 54. You'll end up using both of those problems, both of those relationships, to solve this triangle because I want you to solve for all of the missing sides. But let's start, now that I have this written, let's start by finding side B. So let's see, let's simplify the sine of 32 and the sine of 54. So when I type those into my calculator, I get B over 0.5299 equals 26 over 0.8090. Then I'm going to cross multiply. And I get 0.8090 times B equals 26 times 0.5299, which is 13.7774. Then, since B is being multiplied by this number here, I'm going to divide by 0.8090. So that'll cancel this out. I'll be left with B equals 13.7774 divided by 0.8090, which is 17.03 meters. So side B here is 17.03 meters. And then I can go on. Again, I'll set this up so you can see it. My law of sines relationship now looks like this. A over the sine of 94 is equal to 17.03 over the sine of 32 equals 26 over the sine of 54. So now notice there's two different problems you could set up to solve for A. You could have A over the sine of 94 equals 17.03 over the sine of 32. Or you could have A over the sine of 94 is equal to 26 over the sine of 54. Guess what? You'll get the same answer either way. Okay. So that's it for this video. In the next video, we're going to talk about the ambiguous case. I'll have just a shorter video where I explain what the ambiguous case is for triangles using the law of sines. That's an honors topic. So for this video, hopefully you're able to use the law of sines to find missing sides and missing angles. I hope that was helpful. Please let me know if you have any questions whatsoever, and I hope that you enjoyed that as much as I did.